You ever wonder how an AI just seems to know things? Well, I'm going to tell you it's not magic, it's actually just logic. Today we're going to pull back the curtain on two really fundamental ways that an AI thinks, and we'll do it by solving a simple puzzle together.
So to really get how this all works, we're going to solve a puzzle right alongside an AI. You can think of it like a little mystery. We're the detectives, and our job is to piece together all the clues to find the truth.
Okay, so our whole mystery is about this new pet named Fritz. Now, he's shown up in a box we can't see through, so we have no idea what he looks like. Our mission, our only goal, is to figure out his color using nothing but pure logic. All right, here's what we know for sure. These are our starting facts. 1, Fritz croaks, and 2, Fritz eats flies. That's it. And this is the big question we need to answer, our ultimate goal. Is Fritz green? And this is our rulebook. The AI can only use these 4 simple if-then statements to connect the dots. These are literally the only tools we've got. So let's put on our detective hats and get started.
So our first detective, let's call this one the data-driven type. This approach starts with the clues, the facts we actually have, and just follows them wherever they might lead. It's all about building the case from the ground up.
The official name for this is forward chaining, and it's a bottom-up strategy for a reason. You literally start at the bottom with the raw data, and you chain your way forward by applying rules to see what new facts you can uncover.
Okay, let's see this thing in action. We start with our 2 facts. The system scans the rulebook looking for a match, and bingo! Rule number 1. If X croaks and X eats flies, well, our facts fit that perfectly. So that rule fires, and we get to infer its conclusion as a brand new fact. Fritz is a frog.
And this is where the chain part comes into play. Our new fact, Fritz is a frog, just became a brand new clue. So the system scans the rules again, and what do you know? It finds another match. Rule number 3 says, if X is a frog, then X is green. Well, we just proved Fritz is a frog. So this rule fires, and boom, we've reached our goal. We proved it. Fritz is green. Simple, logical, step by step.
But what if we started from the end? I love this quote. It's actually about teaching kids, but it captures a completely different way of thinking. What if you start with that feeling of success, the goal itself, and just work your way backward?
And that brings us to detective number 2. This one is totally goal-driven. They start with a hunch, a hypothesis, like I bet Fritz is green, and then work backward, trying to find the evidence to prove it.
This is called backward chaining, and it's a top-down strategy. You start at the very top with what you want to be true, and you chain backward, breaking that main goal down into smaller and smaller sub-goals you need to prove first.
Okay, here's how this one works. We start with the goal. Fritz is green. The system asks itself, okay, how could I prove that? It scans the rulebook, but this time it's looking for any rule that concludes with something being green, and it finds rule 3. Now here's the trick. To prove the conclusion is true, you first have to prove the premise is true. So our main goal just became a sub-goal. We now have to prove that Fritz is a frog.
And we just keep going backward. Our new mission is to prove Fritz is a frog. So the system asks again, how can I prove that? It finds rule number 1, which has the conclusion we're looking for. So to prove this sub-goal, we have to prove its premises. So now we've got 2 even smaller sub-goals. Does Fritz croak, and does Fritz eat flies?
And right here, this is the magic moment. We've worked all the way back to the very beginning. Both of these final sub-goals, Fritz croaks and Fritz eats flies, hey, those are our initial known facts. Since the evidence at the very bottom checks out, the entire chain of logic is confirmed, all the way back to our original hunch. Goal proven.
So there you have it, 2 totally different methods, 2 completely different detective styles, but they both got to the exact same answer. Let's put them head to head and see what the real difference is.
It really just boils down to a single question. Forward chaining, the data-driven way, asks, okay, with the facts I have, what can I figure out? But backward chaining, the goal-driven way, asks, to prove my goal is true, what do I need to find?
And here's how that plays out. Forward chaining is bottom-up, starting with facts. It tends to explore all the possibilities at once, which makes it great for things like planning or monitoring a situation where new data is always coming in. Backward chaining is top-down, starting with a goal. It dives deep down one specific path, which makes it absolutely perfect for things like diagnosing a problem or answering a specific question.
Look,
This isn't just some abstract puzzle about a frog, right? These two ways of thinking are actually built into the technology we are using every single day. Let me show you what I mean.
First up, let's talk forward chaining. Remember, this is the data-driven one. A new piece of info comes in, and a system has to react to it. Think about a simple fire alarm. The new fact is smoke detected. That triggers a rule, and the conclusion is sound the alarm. Or what about your Netflix queue? The fact is you just watched another action movie. A rule fires, and the conclusion is, hey, you should probably watch this other action movie. It's all about reacting to what's happening right now.
Now for backward chaining. This is the goal-driven approach. It starts with a problem that needs solving or a question that needs an answer, and it works backward to find the root cause.
This is basically the logic of a doctor or a car mechanic. The goal is figure out why this patient is sick. So the system works backward, checking symptoms. Or the goal is fix this car that won't start. So the mechanic works backward, checking the battery, then the spark plugs. It's a focused search for an explanation.
But really, when you get right down to it, this isn't just about how AI thinks. It's a really powerful way to understand how we think. We all use both of these approaches. Sometimes you're data-driven, just gathering info to see what it tells you. And other times you're goal-driven, starting with an objective and figuring out the steps to get there.
So I'll leave you with this question. When you're up against a complex problem, what's your natural instinct? Do you start by gathering all the data you can find? Or do you start with the end in mind and work your way back? Honestly, just recognizing which pattern you lean into can make you a way more effective problem solver.